Safety Requirement Specification or SRS is very important in functional safety domain. EPC contractors, owner or the end user and system integrator uses SRS at different point of time, and the quality of the SRS actually dictates the quality of the seal loops and the quality of the seal verification and validation. This is a very important piece of the document. We should be aware when this safety requirement specification should be created, who should create it, and what the SRS should contain. So in this video, we'll cover all this aspect. So if you see the IC 61511 flowchart, so we have already covered certain things like hazard and risk assessment we have covered, and then allocation of the safety function to the protection layers are also being covered. So now we are in this stage or the third stage where the safety requirement specification of the safety instrumented system should be specified, right? So we are at this stage now. We have already done the hazard and risk analysis through Hazop, fault tree analysis, or different techniques we have discussed. Then we have allocated the safety function to the protection layer, and this we have done where we are discussing about the safety instrumented function, safety instrumented system. So now the safety function has been allocated to the protection layer. There is a need to specify the safety requirement specification to the SIS, right? So let's discuss in more detail. So as per IC 61511, SRS should contain following documents at minimum. So it should have functional description of all safety function. What is safety function and how to define it, we have already discussed. Then what is the safety integrity level? What is a required risk reduction factor or RRF, or the PFD and PFH? Whether it should be energized to trip or de-energized to trip. Whether this is a low demand, high demand or continuous mode system. What is the safe state of the each safety function that we need to discuss? What is the startup, restart and reset facilities, right? Then we need to discuss about the maximum allowable spurious strip level, environmental conditions and bypass philosophy. So all these things should contain as a minimum to the SRS. And when we are preparing or somebody else is preparing, we need to review the SRS. We need to see whether this information are captured in SRS or not. If they are not captured, we should go back and ask the concerned team about the relevance of the same and why it needs to be captured. Now we need to see what is the SRS flowchart. So first, depending on our hazard analysis outcome, we'll prepare the SRS. Who will prepare? The end user or owner will prepare the SRS first, right? Now in this case, maybe the owner may be associated with some consultant or the EPC person. So the EPC may also prepare the SRS, but ultimately it should be reviewed and approved by the owner or the end user. Then the prepared SRS is provided to the system integrator, or we can say that DCS PLC vendor, and they take this document as an input to create their hardware and software requirements, right? So they, in other words, they create a different version of the SRS which contains much more information about hardware and software requirements. Now end user need to approve the same, right? approve the same SRS prepared by the system integrator. Now with this, the final SRS is prepared. So now we have the input from the system integrator and all the concerned person in it, right? So final SRS is prepared, and now this SRS can go for the design and engineering of SIS, right? So this is the whole flow chart of SRS. When and who should prepare SRS and who should review it and how it should be processed. So this is a simple example of SRS. So it may be some difficult for you to see, but it contains following as a minimum, as a like SIF reference number. It should contain SIF description. It should contain the equipment. It should contain the LOPA, which LOPA report. Then it should contain the hazard description, safety functional description, SIF normal and abnormal mode, right? Special operational modes, which can be startup, batch. Then there should be hazard from any process safety occurring concurrently. What is the target level of the protection layer? What is the target PFD? What is the target RRF? And also some information about the spurious strip, the cost of the spurious strip, and then all the inputs like input 1, input 2, input 3. What is the tag name? What is the description? What is the trip type? What is the trip setting? What is the unit of the trips? What is the tolerance? What is the action on failure? What is the dangerous undetected failure rate? What is the element response time? So all these informations are covered in SRS, right? So this is just an example SRS that I have pulled up.